Thank you very much, Pavel, for the great talk. Uh, Welcome back. Thank you for the presenters to come to with us, and thank you for everyone who is online. Join us with a panel discussion and Q&A session. To start with, given this is a virtual event, oftentimes we don't know where everyone is. So let me do a quick location check. I'm Yun. I'm here in Bay Area, in North California. We have a beautiful day here. Brendan, where are you?
G'day, I'm here in Sydney, Australia, and it's the middle of the night.
Oh, wow. Thank you for staying up so late for us. Andrew, where are you?
I happen to be located just for this week in Lake Tahoe, California.
Oh, okay, cool. Are you having a bunker bed behind you?
Yeah, I used an extra room for this.
Okay.
No
cool.
office in our rental.
Okay. Pavel, where are you?
Hi, so I'm still in the Bay Area, California. I'm enjoying beautiful weather, similar to you.
Okay, cool. I know that I talked to Pavel multiple times last year. I know that every time when I talk to him, he's in a different state, in different house. So that's cool. Brent, I cannot see you. Are you still there? Hello? Did we lost Brent? Okay. Yeah. So maybe let's while we wait for Brent to come back, let me introduce how this session will go. So basically, we have some common topic. We want to ask each presenter to talk about this topic in their domain. We also get a lot of questions from email. At the same time, for anyone who are on the live session, you are welcome to submit the question at the same time. In real time. I will try to get all the questions today. Cool. Okay, I think we can start first. While we are waiting for Brent, I think we can start with some questions. And when Brent shows up, oh, okay, Brent, here you are. Okay, I wonder what happened. Cool. Hey, before we start, Brent, we've asked everyone where they are. Could you tell us where you are?
Yeah. Hey, I'm based in the Bay Area currently. Yeah.
Okay.
So,
okay. Cool. Sounds great. Cool. Let's start. Yeah, the first question I have is for Brendan. Actually, I think it's very interesting that Brendan's talk and Pavel's talk is on the two type of perf analysis. I think Brendan shared a lot of great tips about how to use BPF tracing to analyze performance on a single host in almost like ad hoc fashion. However, in distributed systems, sometimes we need to identify patterns across many nodes. So Brendan, do you have any suggestion on how to analyze large number of traces across machines?
Yeah, a lot of the tools that I use happen right at the end of an performance analysis case where I've picked a host, I've SSH'd on, and then I'm getting to the bottom of something. But before that happens, we've gone through a variety of tools where we're looking at the entire cloud as an environment. And so we have a tool atlas, and there are agents that run on the system, and we have a way of BPF to export metrics. So BPF is great for filling in gaps. So the system, the Linux kernel in particular, already provides all sorts of system metrics, but there are various gaps. And so we can fill in the gaps with BPF and export them to Atlas. And then to look at a deeper level, we have systems for gathering traces and then analyzing them. At Netflix, we published one recently. It was our flow exporter for looking at TCP flows. And so on each of the instances, they have an agent that ultimately exports them to Druid and Hive. And then there's an analysis infrastructure built on top of that. So yeah, there's plenty of different ways to do it. There's lots of systems, open source systems already you can use for gathering distributed data and putting things together. And then right at the end of that, I will log in. I will pick one instance out of a service, log in, and then run those individual tools. But I spent a lot of time there, so when I'm giving these talks, that's not how you start it. You start with your standard tools. You look for ways to bring BPF into the tools you're currently using, and then right at the end of debugging something, you're down to the nitty-gritty tools.
Cool. Thank you much. This is very insightful. So now I want to ask Pavel, because your talk is mostly about how to look at the performance in aggregate fashion. So I wonder, how often do you do ad hoc perf probing on a single server? Like Brendan suggested, think as admin.
Okay. I would say that is less common for us to do. Again, in general, we rely on an approach which is similar to the ideas that Brandon presented about this observability UI. And you have agents that collect data, and the data is stored and aggregated in different databases, and then engineers have user interfaces to explore or analyze this data. There are some cases when we don't have some error counters or error signals or like perf events, or like for instance when there are anomalies which we cannot explain or debug using aggregate data. For these scenarios, like you don't need to like SSH to your host and do additional debugging, but that again very uncommon. Not the most like scalable model, and there are definitely privacy and security concerns. Again, it happens once in a while, but like rare practice in general.
Cool. Yeah, that's very interesting to know. I think a follow-up question I would have is that because you mentioned there are some widely distributed binaries whose performance depends on the main workloads on the host. When you aggregate perf data, would you lose the detail about how whether the performance is really affected by the workload or whether it's a problem for the binary itself, right? So how do you aggregate the perf data for this type of binaries?
So like I would say like the data that we collect, so you get all this like raw perf counters and different metrics, but at the same time, all the samples that we gather have like very rich metadata about workloads that run on those hosts, like data centers and like hardware info. So you have this additional context, and then when you do aggregation, you can slice this data by different workloads, different containers, tasks, and whatnot. And so it's actually extremely important. Yes, so we have this like top level metrics aggregated across the entire fleet, but we look at each workload separately, and the data like in interfaces that we provide allow to do this kind of analysis by different workloads and different containers, which is extremely important because like many performance characteristics are workload dependent, and it's important to do analysis in a context of a specific service. This is very common for us.
Cool. And since we're already on this topic, I want to drill in a little bit deeper. How often would the main workload move between machine, right? If the main workload move between the machine, how would you be able to track whether the widely distributed binaries performance is affected by this workload versus that workload? Or do you need to deal with multiple workloads running on the same machine?
Yeah, I mean, of course, yeah, we can have multiple containers and workloads running on a single host, and like our job scheduler can move them quite frequently from a physical host to another physical host. I think in general, we don't rely on host identity a lot, like host name or IP addresses, because again, even each container has can have its own IP address. Look, we usually rely on this abstract metadata, like container name or job name or task name, and we use that information rather than like actual physical host name, domain name, to that matter. So we're trying to basically abstract us from this physical layer and focus on what exactly is running on this host workload specific context.
Cool. Yeah, again, I mean, given that we're talking about this, another question I'm interested in is that if some widely distributed binaries resource consumption is related to the main workload, how do you set its resource limit, right? I mean, assuming there are different workloads which may affect performance of the binary differently. I don't know, Andrew or Pavel, who will be interested to answer this question?
Yeah, I'll start with that one. So we do have a lot of workload-dependent WEBs, and I think as Pavel mentioned in his talk, we don't have hard limits that we set. We have soft limits and they can be exceeded. The goal of setting our limits in general is to let service owners know, or people that run their services know, what target utilization they can hope to achieve on a given machine. So if we can tell an owner of a service that we believe that you can run your host up to maybe 90% utilization, sorry, you can run your service up to 90% utilization without your host exceeding or getting to 100%, then that's enough information for them to be able to run their service efficiently. So if we can give a guarantee, and this is kind of what our goal is to give a guarantee that says less than 1% of hosts for the majority of services, vast majority, maybe 80, 90 or a higher percentage, won't exceed a certain limit, then for that vast majority of cases, service owners know how much of a machine they have access to uninterrupted. And there might be some small amount of contention in the long tail of services or in the long tail of hosts that we can deal with.
Cool. Thank you. Yeah. Now I want to turn to Brian. So I want to start with a question. There are multiple iterations of system evolution between specialized hardware and the generalized hardware, right? So I mean, I'm old enough to remember 8087 coprocessor for floating point calculation. Later on, and the functionality has been consumed by general CPU. So do you think the future trend of AI and video transcoding will continue to be rely on specialized hardware, or eventually generalized hardware will catch up?
Yeah, actually, this is somewhat of a speculative answer, but as you had mentioned, like I think one of the directions the hardware might take is closer integration of the specialized units with the CPU, and so they may perhaps be on the same die or the same chip, and that way you can kind of reduce the overhead of like shuffling data between say the CPU and like the special purpose accelerator. So most likely that might be one of the directions the hardware might take. Although for some of the applications which are like very throughput oriented, probably like the way it is right now with like a separate unit that does the processing is usually would be good enough. Like I guess perhaps for videos or for inference, if everything can be contained and it's all about throughput, that might still be like, so there might be a world where both kind of systems might live.
Cool. I guess a follow-up here is that you mentioned Facebook use ASIC to accelerate AI inference. What about training? Do they use special hardware as well?
Yeah, so we are considering experimenting with accelerators for training as well. And like in general, like the training problem is a little more complex than inference, because in inference you pretty much it's again like you have data and then you just run it in a throughput manner, right? Whereas in training, I think we need to like have this broadcast communication at every step. So like a lot of these nodes have to cooperate together. So that's why it's kind of like a more challenging problem from both the accelerator perspective as well as the overall system design perspective.
Cool. And there's another question is that nowadays I think GPU is a hot topic in AI, right? So you talked about observability for ASIC. So what's the current observability support level for GPU? Are they consistent across different vendors? And do you see any need to build something similar to ASIC mount for GPUs?
Yeah, so I wanted to mention that like we have like a companion project on GPUs. This is called Kineto. So it's actually an open source project, part of PyTorch. So they have, I believe that they currently support NVIDIA GPUs, and there's already work on the way to support AMD GPUs as well. And it has very similar flavor of ASIC on where there's like continuous monitoring for like the GPU metrics, and then there's like tracing as well integrated, so you could like you could request for a trace and then get a timeline trace of a small time window as well. So yeah, so the Kineto project is already like looking at this, and I believe they have like some talks on GPU technology conference as well that go over this. Like internally, like in the long run, what we want to do is basically have like a common language for traces collected from various systems, like whether it's from ASIC or GPU or from like the kernel or CPU as well. And we want to kind of like have like a combined view so that when someone's debugging, they can look at the CPU trace, maybe BPF trace, or GPU trace in like a single view.
Cool. Thank you. Yeah, so next, I have several questions for Brendan about hosting environment. So the first question is that there are some common performance concern about running application in a cloud environment, right? Either people worry about the cost of virtualization, or people worry about less control of running environment, right? Being that software or hardware. Given that Netflix run us on AWS, so Brendan, what do you think about such concerns? Do you have any suggestion how to reason about them, how to deal with them in general?
You know, things have changed a lot. When I joined Netflix in 2014, Netflix runs the cloud side on AWS EC2. EC2 is running Zen, and nowadays we're now on the Nitro KVM-based hardware accelerated hypervisor. So things have changed a lot, and a lot of the wisdom about the cloud being slow and there being virtualization overheads, I think, comes from early virtualization technologies. And if you go all the way back to binary emulation like VMware and how difficult it was to run applications in VMware instances, there's been so much work to improve virtualization up to today. And so the overheads now, and you can see how we've gone through SRIOV acceleration for networking, for disks. We've already got the hardware as part of CPUs for doing CPU accelerated virtualization. That's been there for a long time. And all of the different resources have ultimately added hardware-based virtualization support. And that's what the latest Nitro hypervisor that Amazon uses. And I'm sure other clouds have their own something similar as well. So yeah, the overhead today, I expect to be negligible, to be very, very small. So it's not a big issue. To monitor it or to be aware of it, again, it depends on the virtualization technology you're using. Back with Zen, if you're running that with paravert mode, then the kernel drivers and the kernel itself would make various paravert calls. You could measure their latency just as a direct measure of how slow is the hypervisor at doing various requests. But nowadays, we're no longer doing that. We're running unmodified guests because there's so much hardware support. And so now if I want to know whether the hypervisor is slowing things down, it's looking at what is the expected device performance, looking at disk performance here and looking at the CPU performance of this and that, and seeing if things are greater than usual. So one example that we've drilled into is the MSR instruction for doing load MSR and read and write MSRs. So they're used for setting PMCs for doing hardware monitoring. They're used for various other things as well. And that will trap into the hypervisor handles it. And so measuring their latency is something that if you end up having a workload that calls this instruction a lot, is something that an example of something we've measured. And so we actually measured that by doing little micro benchmarks to see what the performance of this one thing was. Usually we don't have to do micro benchmarks. Usually if it's disk I/O or network I/O or whatever it is, there's enough places in the kernel you can hook the requests when you're issuing something to the device to when it completes, and then you can compare that versus what you expect for real hardware. But also, you kind of mentioned, like, how does it feel to be abstracted away from the hardware? That's all changed as well. So when I started, you didn't have PMCs, you didn't have performance monitoring counters in EC2. And that meant you couldn't look at level 3 cache misses, you couldn't look at stall cycles, how the buses were being utilized. And so I helped work on some of that, and nowadays the latest generation hypervisors, you do have most PMC access. And so things have changed a lot. So in summary, the overheads themselves are now pretty close to zero, but sometimes something will stand out, and so we'll either trace it in the kernel to measure the overhead or do little micro benchmarks to prove it. And the actual visibility of the hardware has improved a lot as well, now that we have the performance monitoring counter access.
Cool. Thank you much. This is a very deep answer. So you probably already touched this. Maybe I just want to reframe next question again to see if you have anything to add. In general, like how do you know if a perf problem are coming from host OS or hardware? And if that's the case, how would you debug it in a cloud environment?
So, back when there were paravert calls, there were different strategies you could do. But nowadays, you're just running an unmodified guest OS. And so once the kernel does an issue to a device, you can't tell whether that latency is caused by the hardware or a noisy neighbor or the software, the hypervisor software itself. So it is actually difficult. And so part of the answer is to have some performance expectations. And so I know what latency to expect out of different device types. And looking at the latency profile in detail, one of the great uses of BPF, the only uses, must be like, it was the first real demos that Alexei Startoyov and myself were doing, was doing disk I/O broken down by latency as a heat map. And Alexei added this great sample into the kernel source that did it as ASCII. And we really care about these latency heat maps because you can understand latency not as an average or as a maximum, but the pattern at a very fine detail. And so if you imagine you're trying to understand a noisy neighbor or a hypervisor, it's going to bump the minimum latency out by a little bit. So I really need to know where that minimum latency is. It may add some outliers as well, so I need to understand that pattern as well. And so having a really good view of latency helps you tease apart the expected latency from the devices to what the hypervisor or the other neighbors can be adding. That's the case if you're a customer and you don't have host access. There are cases at Netflix where Amazon and other cloud providers now give you bare metal access, so we can effectively run our own hypervisor on those bare metal machines. And then we have direct access to the hardware ourselves, and we can compare that to what basically the guest, either a container or a virtual machine, is accessing. So there can be cases where you do have host access, and you can measure the latency from both points of view and compare it directly. If you don't have host access, you have to infer it, but having the really rich data, fine levels of latency helps.
Cool. Thank you very much. There's a question from live stream which might be related. So at Netflix, do you encounter issues of resource sprawl, such as a VM or container sprawl?
Sorry, what was that last word? Sprawl?
I'm not sure if I pronounced it correctly. SPRAWL. I think this is
sprawl. Sorry, yes.
Yeah.
So the question is, do you see resource sprawl?
Yes.
Sorry, what? I'm not sure. Maybe they should ask in a different way. Do we see resource sprawl?
Yeah, container or VM. So my understanding of this, my understanding of this is usually in the cloud environment. Sometimes VM and container could fail to decommission, or just because how the accounting works. So whether you have seen this type of problem. Unfortunately, we don't have a easy way to clarify the question over the live stream.
Okay, I think I can guess. I might be able to guess what's what's happening is we're a microservices environment, and people create microservices, and when they start life, they're very small, but as they grow, they initially didn't have a need for someone to be having a close look at their performance footprint because it was so small. If it's like 2 instances, then it really doesn't matter. We have over 300,000 instances running. But over time, that can sprawl. And so as load increases, as the user base increases, and now you've got 10 instances, 20 instances, 100 instances. And also, there can be cases where engineers create projects which are doing some sort of analysis, they're doing some sort of study, and then the engineer leaves. And those projects are still running, but no one's using the data. So we have these instances that are just costing us with no value add. I guess that's another case of sprawl where the environment has created extra things. So we have cloud-wide monitoring tools that look at cost, and it breaks down the cost of all these services. And we have a team that analyzes the cost all the time. And so they're looking at growth of services, unexpected growth, but they'll also go right down to the individual instances and see if there's these small services people have forgotten about that are not really being used. And one thing they can do is they can use the other monitoring sources, so they can see if they're handling load at all. If there's no CPU utilization and this thing has been running for months, maybe no one's using it. I actually hear from the team because I create all sorts of weird instances when I'm debugging this, or it's like, oh, I need to have a GPU instance for this, and I need an accelerator instance for that. And sometimes I forget about them, and then I hear from that demand team where they've been looking at their dashboards, and they're like, we think you're not using that instance because it's not really there's no CPU utilization, you deployed it months ago. Like, yeah, sorry, I'll go and decommission that. So yeah, I don't have a great answer for sprawl other than we have a team that does it. They have dashboards, they monitor it, so it's a very human activity. I guess as programmers, you could think of clever ways to do it, like looking at network traffic and CPU traffic and trying to determine, is this instance dead? Is no one using it? Maybe those tools will continue developing in the future.
Cool, thank you. So for people on the live stream, if you want to further clarify a question, please feel free to comment in the live stream or maybe follow up with us offline. Cool. I see another question on live stream for Brandon related to this group of topic. Are there any ePPF tools specific to containers?
Well, a lot of the container performance issues I've debugged are system performance issues. And so you've got too many processes, disk I/O, and it's just the same tools. I'd say 90% of the performance issues use the same tools. For specific container issues, we have been creating them. I have been adding switches. And so, for example, the scheduler latency, I added a switch so you could break that down by C group so that you could see if one container was experiencing high scheduler latency versus others. But really, anytime there is a performance need, there's a high likely chance we can create a BPF tool for that. And so in particular, I want to see some of the work I'll be doing in the future includes having a tool that tells us the performance overhead or the latency that your container is experiencing because of the hardware versus the other neighbors. Because people are frequently wanting to debug, is issue me, or is it the container, or is it the hardware? So you have to separate those three scenarios. All the data is there in the kernel, right? We can. So whether it's disk I/O, we're doing networking, scheduling, you enter queues, and it can all be done. We just have to sit down and create all the tools. So we've been doing it on an as-needed basis, but in the future there'll be more of these tools which give you the breakdown of you, neighbors, hardware, and then you can determine that straight away.
Cool, cool. Thank you. Yeah, now I want to turn to Brian. Similarly about the environment. So how would someone tell if the performance problem is coming from software or hardware?
Yeah, that's a really great question. And in general, I think like this, figuring out if it's coming from software is usually easier, and that will be the most common case. So with the help of the trace, so once we collect a trace, and we can kind of see events happening both on the CPU and on the accelerator, like from software perspective, that's usually the best place to find software issues. And they could be things like either scheduling, or sometimes there'd be like a lot of overhead to launch a kernel on the accelerator. So those kind of issues are easier to find, and then we can fix them by like batching or kind of changing the repartitioning the model and things like that. On the hardware ones are actually slightly more difficult to figure out. So like on a high level, you can kind of find those by so we look at like the aggregate performance counters. Like, for example, if the communication is bottleneck, so then you could see the PCI bandwidth is kind of high, and so you know that there's like some issue due to communication, or there's an issue due to the memory or the cache on the accelerator. So usually those are like pointers you could get to kind of figure out if there's a hardware problem. Like a more sophisticated approach is also like you could kind of model the time that the model or the operator is going to take. You can do some kind of data modeling, and you have like an estimate that this should run within these many nanoseconds. And if you don't see that, you kind of can pinpoint that maybe there's a hardware problem. But yeah, it's usually more harder to figure out these hardware issues.
Cool. Yeah, so next question I have is for Pavel, similar about running about the hosting environment. So when the application runs in a centralized managed environment, they tend to have less control over software and hardware in terms like how much you can tune on OS or how much you can configure your hardware. That may make performance optimization harder. Is there a concern for Facebook?
It is a good question, and I think it can be a concern. So of course, like you have this operational complexity that we would like to minimize. At the same time, we can lose some optimization opportunities, some potential performance wins and efficiency wins. I would say that our strategy is to find the right balance between this complexity and capacity savings. So in general, we're trying to avoid like very fine-tuned customization and workload-specific settings. But at the same time, we provide capabilities for services and workload owners to apply some to change some software or hardware settings if the scale of capacity and performance wins can justify this additional complexity. So that's something we do when we provide again this functionality. It's just a big problem by itself. Like as you mentioned earlier, tasks and jobs and containers can move from host to host, and there are multiple tasks running on the same host. So it's not something you can easily implement. You need to deal again with all those constraints. But that's something that we do. But again, this custom settings are usually used only for some larger services. In this case, those performance wins are so huge and take definitely like bigger than like additional operational overhead.
Cool. Thanks. So next question also for either Andrew or Pavel. Do you use BPF for profiling the widely distributed binaries?
Yeah, I'll take that one. So the answer is yes. We do use BPF. We use BPF to collect all of the hardware performance counters on our hosts. And we actually do that through a daemon that runs on every host, which means that it is a WDB itself. So anything that runs on a host is monitored by this daemon. We collect and aggregate the data offline and can use that for analysis. And because it's BPF, we can do all kinds of fun triggers and that kind of thing. We can turn on additional sampling, collect additional counters if CPU utilization is high, if a particular application memory usage is high. other things like that. So yeah, yes, we use BPF for collecting these hardware counters.
Cool. Yeah, no question for either Pavel or Andrew. Any insights? I think this is a live question. Any insights about performance inference in case of the setting soft limits?
Yeah, so I think I saw that question come in when I was giving a previous answer about the fact that we allow some contention because we don't set hard limits on the aggregate usage of WDBs on our host, which means there are hosts where service is contending with the WDB usage. And so we monitor for that. And I think the best interface for monitoring that is the Linux resource pressure metrics, so we can get those on the level of any particular C group or in aggregate for the host. So if no particular C group is under memory pressure or I/O pressure or CPU pressure, but the host itself is facing pressure on some of those metrics, that indicates that there's contention and that the containers aren't adequately providing protection against it. So that also kind of implies that one of the solutions that we try to put in place to prevent that is to make sure that hosts put up resource limits on their own containers. So a particular service is less likely to contend with anything else on the host. Same for WDBs. We encourage them to set resource limits as well.
Cool, thank you. Next, we have a set of questions about how to manage BPF scripts itself for Brandon. So I guess the first question is, how do you know the BPF scripts themselves are not causing performance or reliability problems?
Well, performance overhead, I think this is going to be the next big challenge for BPF. People are discovering it. Well, it's great. I can monitor this. I can monitor that. I've got container issues. I want to understand noisy neighbors. Let's add monitoring for this and that. And before you know it, you've actually monitored a lot of things. So, and for just using that as an example with containers, since the CPU scheduler is in charge of who runs, am I going to run this container or that container? Am I going to make you queue? By instrumenting it, you can know exactly the overheads of being in a container and what the other things are doing. But scheduler events are really frequent. And so that's one of the things I'm a little bit cautious about instrumenting permanently, like 24/7, because of the overhead. So as one answer for this is, having done tracing for decades, I have a very strong understanding and expectations of what are high-frequency events and what are low-frequency events. Low-frequency events, you can just go to town. You're not going to even notice the overhead of tracing things like disk I/O, new processes being launched, new threads being launched, and other low-frequency activity like page faults. But I also know what are high-frequency events, like scheduler events. If it's memory allocation, tracing malloc, it can be very expensive to do that. Tracing, depending on if you're doing uprobes for user space libraries and so on. So part of the answer is, I have all this knowledge and wisdom. That doesn't help you if you're new to BPF tracing. I think that a lot of people will learn this the hard way. So one thing you can do is perform experiments in the lab where you try and stress test. So if I'm developing a new tool, and let's say it's an area of software I'm just not familiar with, try to write a benchmark that stress tests it, takes the CPUs to maximum, and then look at its throughput normally and then with your BPF tool running. And if your BPF tool makes any sort of measurable difference, you might have a problem. So ideally, like if I'm doing a disk tool, running FIO, the micro benchmark tool, with and without my instrumentation tool running, I shouldn't notice a difference. If I notice a difference, I've done something wrong. But there are other ways to measure BPF overhead. And so the BPF tool you can use to list out what programs or BPF programs are running on your system. And it's beginning this whole universe of basically system administration of BPF. I said this recently, people will be annoyed at us when they realize that we've doubled the system administration duties on systems. Not only do you have processes you have to look after, Now you have BPF programs you have to look after as well. And instead of PS-EF, it's going to be BPF tool, prog show, and we basically need the Rosetta Stone of mapping traditional Unix admin to BPF admin. So yeah, it's a matter of what programs am I running, check the frequency of events. One thing you can do is just turn them on and off. If that's a quick way to determine if something is, if you have a performance issue and anyone's thinking, oh, maybe it's the BPF programs, just turn them off and see if the performance issue goes away. Like, that's a very quick test you can do, especially for observability tools. But there's been lots of work in BPF about understanding the overhead, including getting the symbol information from the BPF code available so that you can do the non-maskable interrupt-based profiling, build a flame graph, and actually see some of the BPF programs in the flame graph because it's got the symbol information out of it. And also BPF, we're looking at adding timestamp information, and you can do it yourself manually so that you understand the time for each of those programs to run. But yeah, I think this is a big challenge going forward. So people who discover BPF, they're going to be running lots and lots of programs. And now we have this new thing we have to do, which is BPF system administration or BPF administration, where it's listing all the programs you're running. What's the overhead of each of those programs? Are you instrumenting something that's too frequent? If you're instrumenting something that's too frequent, look to instrument something that has a lower frequency. Like at Netflix, everyone's running my TCP Live program is now the Netflix TCP flow logs. And a lot of people, if you said, hey, I want a tool that monitors network flows, they'll begin by tracing every packet. Like, don't do that. We can have millions of packets a second. That's high frequency. So what I did instead was I only trace TCP session transitions. So when you go from SYN receive to established to close, they're low frequency, really low frequency. You might be doing 1,000 of these a second on a really busy server that's also doing over 1 million packets a second. And so that's the other thing about BPF observability is you try and come up with clever ways to answer the problem that's not the high frequency event, but by doing a low frequency event.
Cool. Yeah, this is a pretty comprehensive answer. I guess a related thing is that then having too many tracing lingering around might be a problem, right? So for so many years we have invented different tools to manage our source file or libraries. So how would you suggest people manage BPF scripts?
Do you mean like programs running 24/7 or a collection of like tools to use? Because they're different answers.
Yeah, I mean, just I think it's because if you suggest people to think as admin, then it kind of suggests people may ad hocly when they see a problem, they start to create a script to measure this, measure that. So in terms of just the management, like how to track how many scripts you have, what's the stage are they, whether this thing has been turned on or not, is there any easy way to manage that, right? So I think for years there are for source code or for library, we kind of struggled in just the lifecycle management for those things themselves. I wonder whether BPF scripts will have similar problem.
They're going to have a big problem. So I've already mentioned the overhead problem, right? There's a whole heap of work we have to do to like monitor it, list the programs that are running, profile them, understand their footprint, all of that stuff. Then there's the tools themselves and all these little programs people write. BPF is a superpower because you can use dynamic instrumentation to attach to any kernel function or user space function. But that's an unstable interface, and those functions will change from one version to the next. And so a growing problem is you have these tools that used to work, but they don't work on the latest version of Linux. If you're lucky, they blow up or they print total garbage. If you're unlucky, they're just subtly wrong. They're wrong by 10%, and no one notices, but now you're making business decisions based on bad metrics. And so this is another problem that we're going to see going forward. And I've done dynamic instrumentation for a long time, coming up to 20 years. So what people need to be aware of it. So anytime you do dynamic instrumentation, it's going to require maintenance. But also, one thing that I'd recommend people do, and I mentioned this a bit in my talk, is that try to stick to basically the upstream versions of the tools. And so I've written this instrumentation that's in the BCC tools and BPF trace. Some people want to do their BPF observability agents, and they begin by porting the tools to the language of their choice. Well, these tools are going to require maintenance because the kernel versions will change. And so you, if at all possible, try to stay on those upstream versions so that you can keep pulling in updates. Otherwise, you'll have the situation where you've got this tool that appears to work, but it's actually, especially when kernel engineers, they'll add a fast path to something, but the slow path still exists. So when you run the tool, you still see activity and you think, things are okay, but you're missing the fast path activity events because it's just not instrumenting them at all. And so pulling from these upstream repositories instead of rewriting them in languages, if you can avoid it, will help. Also for tool creators, there'll be a time when we've created too many tools and you have these old, dusty, rusty repositories. We have to think carefully about who's going to maintain them going forward. And I think if it's let's say I create a whole heap of tools for Apache Spark, I should try to put them in this Apache Spark repository so they live with the code, and the engineers that look after Apache Spark look after those tools. If I wanted to create a bunch of tools for Python instrumentation, maybe they should belong in Python itself, in the Python source tree, again, so that it's one place, it's where the engineers who are authoring the code, it's sitting next to them, because they can be so tightly woven with the code they're instrumenting them that you should think of them as patches. These are basically these wonderful patches that you like using. It's like, well, if it's patches, then they're going to require updates. So having them live close to the repositories is a good approach here. But yes, it's a good question because it's going to be a growing problem of people having these old tools that used to work on Linux 4.8 but don't work now, and how do we maintain them and look after them going forward?
Cool. Thank you. Next, we have several questions about how the tools we talk about integrate with ecosystem. Let's start with a question for Brian. There are different traces, and the tools to realize them. Will ASIC mount tracing be compatible and available in existing tracing tools?
Yeah, thanks, Yun. So yeah, the goal definitely is to be not to be tied to like a single visualization, and so the idea is to be able to support like different visualization tools. So currently we already support the Chrome trace format, and that can be visualized in the Chrome browser. And we have an internal visualization tool at Facebook, which we also support. And so going forward, right now we kind of save the trace in Chrome trace format because that was easy to start out. But we're hoping to kind of move to some kind of a binary format, so that's more standardized. And then the idea would be that could be translated to any trace format that some visualization tool will support. So that's the direction we'd want to go into. Yeah.
Cool. I think a related question from live stream for Brian is, generally, is there any plan to open source ASIC mount or ASIC move?
Yeah, we definitely want to like follow up offline on like trying to like learn about the use case about that. I guess we just never ended up open sourcing it because we didn't have enough time to actually like work on that part of like making it open source. But it's definitely something doable.
Cool. Yeah, so similarly, a live question for Brandon about this very similar topic. Is there any integration done by any existing monitoring tools for BCC or any in-dev or any tools like in that process?
Within Netflix, we are building our own UIs that sit on top of them. And as I said before, we're not going to port the tools. We just want to keep fetching the upstream versions and then building upon that so that we have all the latest updates. As for tools, building upon them, I've seen people do things with Prometheus and Grafana, and we're doing that stuff at Netflix as well. There's just going to be lots of it. And so various commercial observability companies are picking it up as well. And this is actually good timing for the talk I just gave, because a lot of people are at this point of, how do I add BPF to my observability product? And so that's why I wanted to talk about all these sort of challenges as well. It's very good timing. So we will see lots more of this in the future, BPF getting added to different products. There's also there's something that I did mention in the talk that's really changing things as well, and that is BCC is the main repository that we started with, and we have lots of tools. It's the BPF compiler collection. All the early stuff was written in Python, but the new stuff is written in libbpf, C, and so that's using BTF and Core. These are these great technologies that Facebook helped develop. So BPF is the BPF type format, and Core is the compile once run everywhere. And the end result of that is the new BCC tools get compiled into these standalone binaries that have no dependencies. They don't require LLVM or Clang. It can be a 100 kilobyte binary that contains the BPF bytecode inside it, and it's relocatable, so you can run it on different kernel versions. It's pretty amazing stuff. That requires the latest Linux kernel. So that kind of requires Linux 5.8 to have everything working well. And if you talk to observability companies, they only build for what their customers are running. So if you say, hey, there's this great thing, it's on 5.8, they'll say, okay, we'll look at it 2 years from now. So they kind of wait until their customers have that latest kernel version before they'll really invest in adding it to the agents. So I think at the moment, we do have some traction with people building upon the Python BCC stuff, but there's going to be a whole heap more traction once the industry has switched to these newer kernel versions. And you can basically do an apt-get install BCC binary tools, which might be, let's call it a 2 megabyte package that contains dozens and dozens of tools. And that's it. There's no dependencies. By the way, when that happens, I'll be talking to Canonical and everyone else saying, this should be a default install in the distros, so people don't even have to add it. Once that happens, then you can imagine that will even more accelerate adding BPF to all of these GUIs and observability agents, because all the binaries are basically there and they work, and there's no excuse. There's no heavyweight dependencies or anything you have to add.
Cool. Thank you. Yeah, so we got a question for Bren. Do you expect the AI model developers to debug performance issues related to accelerators?
Hey, yeah, of course, I guess we don't expect the AI model developers to fully understand the system. So maybe that's not necessarily that they would be able to debug all of the performance issues. But I think there definitely is some value in just exposing a high level view to the model developers, so they do have some idea of why maybe the model is performing bad on inference. And generally those issues could be very simple to fix in the model. Maybe they're kind of overflowing on some aspect of memory, or there is a lot of to and fro communication between accelerator and so on. So the future, I guess the future of making these models run faster will be in co-designing the model with the hardware. So there will be some aspect of that involved, but there's definitely value exposing some high level metrics.
Cool. Thank you. Next, we have a question for Andrew. Does Facebook use sidecars? Why or why not? If yes, how do you manage the cost of sidecars?
Right, so this is a good question. I think sidecars are a good example of workload WDBs for us, because they're closely linked to whatever applications they're working with. So the answer is yes, we have sidecars. We have a lot of different libraries at Facebook that have to be integrated into applications written in various languages. There's bindings and there's sidecars that run for Python and some other interpreted languages. So the way we manage these costs is actually relatively straightforward for us because we're using C group hierarchies with systemd. So each WDB is managed as part of a systemd unit, and any process that's forked from the application within that unit is going to be accounted for as part of the C group costs within whatever unit or whatever C group that's in. So this is kind of handled inherently in the hierarchy that we've set up, and we can account for costs, and then we can further differentiate between the processes running within that C group if someone wants to be able to know what's the cost of the sidecar relative to the cost of the main binary.
Cool. Yeah, so I think we have a live question, I think is for Bren. Bren, please let me know if you have any insight for this question. What is the trend in industry accelerating AI processing stage modeled as service functions?
Yeah, I think I believe this is like talking about like by serverless functions, they're talking about AWS Lambda or something of that sort. Yeah, so I may not be the best person to like the full trend. I think in my opinion, like I think one of the major challenges would really be on the compiler side for the AI model. So whether it's like the compiler or the PyTorch framework that you're using. So yeah, most of the difficulties with like running on like special purpose hardware really come from making sure that the final model gets mapped in an efficient way to the accelerator or the GPU or CPU. And I think that's where I guess like bulk of the work will be in. Is trying to make sure that things actually run well, and the model developers don't have to like do a lot of custom work when they are kind of specifying the model in, let's say, PyTorch or TensorFlow or whatever framework they use. But yeah, I hope. Yeah, sorry, I don't have a very clear idea of that.
Cool. I mean, this is actually pretty helpful. Yeah, so we have one question for Andrew. What will happen if a widely distributed binary reaches a memory limit? Will it be Woomkill? What if it's performing a mission-critical operation?
Yeah, this is another good question, and it goes back to some of the other stuff we've talked about. In general, a lot of WDBs have soft limits or no limits at all. And examples of these would be things that basically run our container ecosystem or some package managers and things like that really we can't live without. And there's other WDBs where we do have some resource limits, some of which are soft and some of which are hard. If they're hard, then yeah, we will invoke the killer. We will kill those binaries, and hopefully they start up better the next time. In the case of soft limits, we're usually referring to things like memory.high, which is a C group feature, which will induce memory pressure. So the kernel will free up memory resources as best it can for that C group, page cache or whatever else, so that the total memory usage at any given time should be lower. But that may have some trade-offs with I/O or CPU or duration, or like program runtime, because now you can't fit all of the memory you need to run your application. You can't have all the memory you might want at one time for your application. You have to kind of spread it out over a longer period. So hopefully that answers that question.
Cool, thank you very much. I think it's time for us to wrap up here. So thank you for all the presenters to sit with us to answer all those questions. And thank you for everyone staying online. Actually, see through all the past 4 weeks of the talk. Today, this session kind of concluded this edition of System at Scale conference. We are still organizing the next edition in 3 months. So please keep in touch. Please, watch for all the, announcement. Welcome everyone to join again in 6 months, in 3 months. Thank you very much. Goodbye.
Yeah, bye.
Thank you.
Bye.
Thanks.